ChrisColbert. I work for nthought. I working on a little project I guess it's been about a year now in development. It's called Enaml. And it's a new framework for writing declarative user interfaces in Python. Anybody that's ever sat down and actually had to write raw WX code or raw Qt code, writing GUIs is not fun. It's like the results are fun and it's nice because you get to see something and play around with it. But getting there is tedious and it's painful. And we'd rather not do it if we don't have to. So the goal of Enaml, GUIs made easy, that's kind of like the moniker. Like we're trying to make GUIs so easy that it doesn't really even enter into your mind when you're developing an application anymore. Just an afterthought, let's use Enaml, make the GUI an easy way, and spend time focusing on our data models. So if anybody's ever done any GUI development before, you're going to have heard of the MVC pattern, the model view controller pattern. The basic concept here is you have, on the bottom of my screen, I've got a model. You've got a model. It represents a person. They've got a first name, a last name, and I want to create the view on the top. It's a basic form thing. You've got a couple labels and a couple fields that you use to edit your model. And you want to connect these two things together. That's where the controller comes in. You've got your model, you've got your view. You want to use a controller to wire everything up. And maybe you're going to throw in some conversion and validation there. Let's say you want to take whatever the user inputs and make sure it's all lowercase. That's how I'm going to store it in my database or whatever. So that's a typical programming pattern you're going to see a lot when you do GUI development. The goal of Enaml is to make this part easy. Writing your views, writing your controllers, let's make that as easy as possible. Let's even remove it from consideration in our projects, and let's really focus on our efforts on making our models good. So this is what we're trying to do here with Enaml. Some existing approaches to this. Anybody use Visual Studio, Forms Designer, written any XAML, right? Okay. Humans shouldn't be writing XML, right? It's designed to be read by machines. I don't know, I don't know why you would want to write that. So Visual Studio, it's a great program. You can write some GUIs, but you're writing XAML. It's not that fun to do. Xcode. Xcode, you only get a GUI designer, and Apple generates the code for you. So there's some argument there whether the workflow is nice or whether it's not, but you're stuck to Objective-C, and that's what you get. Qt Designer is kind of a little bit better than both, I would say. You get a drag and drop GUI builder. It's generating XML in the background, but you don't have to type it yourself, and you don't have to parse it yourself. It's handled by the framework. But you're still kind of, it's not as nice as we'd like it to be for writing Python applications. So what is Enaml? So Enaml is a Python-based markup language, meaning the language itself is based on Python. To be more specific, it's a strict superset of the Python language. What that means is that any Python file you write is a valid Enaml file. However, not every Enaml file is a valid Python file. So Enaml is an extension to the Python grammar. We'll see what it looks like a little bit. Contrary to what the other frameworks like Visual Studio, Xcode, and Qt Designer allow you to do, most of those tools, you have to specify properties on your models, and then the framework will bind to those specific properties for you. You limit it, you get properties, and that's essentially it. With Enaml lets you to bind to arbitrary Python expressions. So if you ever wanted to do a transformation and have something automatically update based on a dependency in that transformation, Enaml lets you do that, and it hooks up everything for you automatically and seamlessly. Contrary to all of the other solutions where either in the case of Xcode where the code is generated for you, or in the case of XAML where it's translated for you to the CLR, or in the case of Qt Designer where it's just interpreted XML, the markup in Enaml is actually dynamically executed. So Enaml files, when they're parsed by the Enaml parser and compiler, actually get compiled down to Python bytecode and they execute on the Python virtual machine. So it is Python code that's executing for you there. And we also have a constraints-based layout system, which I'm going to talk about extensively at the end, which kind of just blows all the other approaches out of the water. So that's kind of the big selling feature. So some key framework features. Robust and automatic expression analysis. I'm going to talk about that here shortly. Constraints-based layout, another big thing. Anybody that's basically had sizer hell in WX or couldn't get Q layout, box layouts to do exactly what you wanted, or one of those really pixel-perfect layouts, we've got a solution to that, and it doesn't have anything to do with box layouts or sizers. It's actually really nice. And model framework independence. I'm not going to touch on this too much, but so we do have most people here are going to have heard of traits before, traits and traits UI. So it's another technology at nthought. Enaml is built on top of traits, and it understands traits models by default. However, it's not limited to traits models like traits UI is. So Enaml does expose hooks, so if you have some Django models or you have some other notification model, your own model framework that you want to hook up to Enaml and have Enaml run your UIs for that, that's possible, and it's a first-class citizen and part of the public API. So what kind of examples can we write with this? So this example, the view for this, it's an image processing algorithm. Just runs a little edge detection in the background, and basically it updates the image in real time. And you have some tuning parameters over on the left-hand column. The entire view for this application, so this is not including the image processing code, but the view was 150 lines of code for the entire app. And that's hooking up all of your controllers, all of your views, all of the data processing pipeline, 150 lines of code. This example I'm going to demo here just shortly. This is a clone of the image viewing portion of OS X Preview written in 200 lines of code, inclusive of all of my model lines of code. So this is the view and the model in 200 lines of code. And to demonstrate that, I'm actually going to fire it up here real quick. So let's actually see what I can get with this here. Hopefully it doesn't take. So app starts up immediately. There's no real long load time for Enaml applications. They fire up if you don't have a lot of models to import and you're not doing a lot of crazy busy stuff on import, the apps fire up almost immediately. So what I have on the left here, I've got a little pane that it's basically a file system browser. I can navigate directories, come back up a directory. This file system browser is all written in Enaml. You'll see some syntax in a minute. When I switch to my thumbnail pane, I'm going to go out and load recursively from this directory down all the thumbnails in this directory. They're loading on a thread. The UI is asynchronous. It's updating however I want. When I click on the thumbnails, I get a little viewer. This is the car I park next to in the garage every day. So it's an image viewer app. I mean, it's kind of inconspicuous, but it does exactly what you would expect to do from an image viewer application. My little dock pane over here, I can drag it out, move, and my layout for my thumbnails goes from a vertical column to a horizontal column. That happens for me in one line of code. That I write in Enaml to do that. I can undock the entire thing, and my thing of thumbnails is now a grid. I can grab a slider down here. I can resize these. It's basically, it's what you would expect out of a real application that only happened to take me 200 lines of code to write. I can double click on it, send it back to the dock. So these are the kind of applications we want to make easy to write. Rich user experience, we can interact with them. It's unobtrusive, it works so well, you don't think about it. And that's basically, it's the Apple thing, right? The interface is so seamless, you don't even think about it. So that's what we want to write, and that's the goal we're trying to solve with Enaml. So what does the code look like, right? So this is going to be an example that's kind of redundant. You never actually write it because it's so simple, but this is kind of going to step through what it looks like. So on the left pane, I've got a model. It's written in traits. It's just modeling a person. They have a first name and a last name. And on the right, I have the Enaml definition for a view, for viewing this model, where I put all of the data I want from the person into a form. So the way that this works and the way that I connect both of these, if I were to create an instance of this person, let's call his name John Doe, and now I need to take the instance of this model and I need to hook him up to my view. So I take this handy dandy with enaml.imports, this magic context manager, and now I can import from this view.enaml file. So when I say from view, import view, Enaml's going to go out. It's going to find the definition of view in this file. It's going to compile down that declaration into executable Python bytecode and hand me back a view class, which I can instantiate like any other Python object. And when I instantiate an instance of this view, I'm going to assign person, this attribute that I have declared up here that I'm pointing to with the blue arrow. I'm going to assign that person a reference to John. And whenever that happens, Enaml's going to go through and it's going to see where all the dependencies are John on, where John are in my expression, and it's going to bind all of those handlers up for me. And when I do that, these little orange arrows here are kind of pointing from the value attribute on the field back to the attribute on the person that's referenced there. So Enaml has basically introspected my expressions for me, found out where those dependencies lie, hooked up all the notifiers to basically automatically bind up those dependencies and that communication protocol for me. And when then I go view.show, and I get a UI that comes up. It's a form layout. It's got a label for each name, and then it's got a little field where you can edit the attributes on the guy. So that's kind of nice. So what's going on with this over here, this little colon equals operator? What is that? So like I was saying before, Enaml is a strict superset of the Python language. So we've extended Python. This is obviously not valid Python over here. If you tried to run this through the Python virtual machine, you get syntax errors all over the place. However, what we've done is we've extended Python with a couple of keywords. There's an Enaml def, which allows me to define an Enaml structure. Underneath this block of Enaml code, this Enaml structure, it's got a grammar associated with it. I'm not going to get into it entirely because it takes quite a long time to explain all of the corners. But you can kind of get the idea here. I've got view, which inherits from main window. That's a built-in. And then the children of that main window, it's got a form, which is a central content, and then 2 labels and 2 fields. So just by looking at the code, you kind of already get an idea of what the UI is going to look like. And with this colon equals operator, this is one of the new grammar constructs we've added to Python, which is a binding operator. So the semantics of binding expressions to your attributes in Enaml is subtly different. And this colon equals operator happens to indicate delegation, and I'll explain all of them independently in a moment. So one of the big features of Enaml is binding to your attribute. So I've got a Python expression that I want to shove in. I want to compute this expression and shove it into a view. And so we've got operators that do this for you, that introspect your expressions and pick out all the dependencies, and they're extremely robust. And by robust, I mean they can track almost any dependency in an expression. This allows the user to not worry about hooking up bindings. So there's no .bind in Enaml. Like, you don't have to bind to any events on your UI. You just take an attribute on your UI and you shove it into your model, and vice versa. So you don't have to worry about hooking up notifiers. You don't have to worry about managing connection lifetimes. All of that's done automatically. So what does that mean? So let's look at an expression like this. It's a horrible abomination of an expression. You should never write it. If you do, you should have your keyboard privileges taken away. But basically, so let's look what's in here, right? If we point everything out, we've got a call to a function. That returns some value. We've got some local variable lookups. We've got some indexing. We've got attribute accesses. If you tried to throw this at a static analyzer for Python, it would fall over. There's absolutely no way that you can track all of the dependencies in this expression statically. Python is far too dynamic of a language for you to be able to do that. You might get a little way of the way there, but you'd never get all the way there. So what Enaml does is it's monitoring the execution of this expression at runtime. So as this expression executes, Enaml is actually monitoring the Python bytecode stack as things are pushed and popped off of it. And it's inspecting these objects live at runtime as the expression executes, and pulls out what all the dependencies are. So you're not going to hide a return value from this boss function from Enaml. Whatever it returns, if it has an attribute on it called info that Enaml can listen to, it'll hook that up for you automatically. As a corollary to that, list comprehensions work too. So if you were to try to throw a list comprehension at a static analyzer, what would happen? Because Python iterators are dynamic, so you never know what you're going to get out of this list comprehension until you actually execute it. But Enaml will track this just fine, because the list comprehension is actually introspected as it's executing. So we can track, basically, Enaml has no problem tracking the name of every person in this list of people at runtime. So, all right, so operators. So language wouldn't be much better than, let's say, Visual Studio or Xcode unless we gave you more options of how you want to bind up your expressions. If it was always you could only bind to properties, that would be kind of useless. We wouldn't be any better than the competition. So Enaml actually provides 5 different operators which can be used to bind up your expressions. And each of the different operators behaves in a different way based on the use cases that we found when writing UIs and for what we need. And so these obviously are, because there's so much a variety of the operators, it's going to allow you a powerful way to express your applications. And I lost a slide here. I don't know what happened to it. Give me just a second. Well, PowerPoint hates me today, so I will explain them off the cuff. So we found in use cases there's 5 different things you want to express when binding an expression. One is default assignment. I've got an attribute. I want to set the title of my window to this, and I just want to assign it one time. So we do that with the equals operator, so the normal equals. Do I have some? I do have markers. Yeah. Can everybody see this board up here if I write on it? So the first operator, the simplest one, the equals sign. It does exactly what you would expect. You write an expression, it gets evaluated, and it gets assigned to the attribute in your UI. The second one, which you saw on a previous slide, is we've overridden the left shift operator. And it only applies to its use case as an operator. You still have the use of the bit shift operator in Python. What this does, this is our subscription operator. So anything on the right-hand side, as that's executing, Enaml is dynamically introspecting the execution of this expression, working out the dependencies. So if any of them change at runtime, the expression can be reevaluated and the UI updated. So it's just exactly has the semantics you would expect of subscribing to something. We have the inverse of that. And basically this means whatever is on the left-hand side of my expression, which is the attribute of the UI, if that ever changes at runtime, so I click on a button and it emits a clicked event, or let's say I change the value in a field and so I need to push that somewhere onto my model, this is what we call the update operator, and it allows you to push a value back into your model. We have a combination operator that does both. This is the delegation operator, so a colon equals. This is what you saw in the very first slide, that example that I put up. Basically what this is saying is if my model ever changes, or if this expression on the right-hand side ever changes, I want to update this attribute in my UI. Or if the attribute on the UI ever updates because the user types into a field, I want to push that value back onto my model. So it's basically a combination of subscribe and update. And then the fifth use case that we had, we're calling it the notify operator. It's a double colon. And this is basically my UI emitted some event, like I clicked on a button and I want to execute a block of Python code. So basically you can new line indent, write any Python code you want, and that will execute every time your clicked handler runs. So those are the 5 operators. Those are the use cases that we needed to supply out of those. 5 minutes left? Wow, that was fast. All right, so the other big feature that we have of Enaml is a constraints-based layout system. So what does that mean, and what can we do with it? Well, anybody that's ever done any work with like box models or anything like that will realize that there's absolutely no way, no chance, no how that you're going to do a layout like this with box models, right? So this is a completely ridiculous example. But basically what I've done is I've defined constraints on every one of these buttons that lays the buttons out in a ring based on the shape of my window. And as I resize this, it lays out exactly how you would expect things to go. So you can do really powerful layouts with that. And I'm going to go skip ahead. I talk more about layout, but I have like a what's next thing. So one thing that that people have asked me all the time is what, I can't type and talk at the same time. They want non-blocking UIs, right? So I've been working on a feature branch. This is kind of like what's coming, what's next. I've been working on a feature branch that basically converts all of Enaml's internals to be asynchronous. So what I've got here is I've got a very simple layout. As I move the slider, the control of my UI updates. This is great, and it looks exactly the same as you would write normal Enaml code, except everything's firing asynchronously. So what are the implications of that? Well, let's say I got tired at work. I got tired of working at number 33, and I came home and I wanted to pick up where I left off. So I just spawned another process, and now I'm sending events over 0MQ, and I've got my one application which is serving the view, and I've got another client that just hooked up to it. And so all of these are bidirectional, so if I mess with the server, my client updates, and vice versa. If I want to pause my DVR and go to another room, I can fire up another client and kind of keep working exactly where I left off. But wait, this is all rich client, you say. What do I do if I want to go and use something for my iPhone? Well, so we can actually handle that case too. With luck, this will work. And I can pick it up from my iPhone on my web browser and run it over the web as well. So 20 minutes is a short time. I'll be sprinting on Friday. Anybody that wants to talk to me afterwards, I'll be out in the hall. So thank you.
2 minutes for questions.
Yeah.
Thanks for writing this.
You're welcome. No. So if you have the traits code, the model code that you write doesn't need to change at all. Yeah. So this will work seamlessly with any existing traits models you have. Yep. Yes.
Do you omit can you call the Enaml without using the Enaml compiler? Does it map all to a bunch of Python classes?
No, so Enaml does things that you can't actually do by writing raw Python code. So there's bytecode that's generated by the Enaml compiler that you just physically can't generate by writing Python syntax. So basically, right, Python's got a virtual machine under the covers, right? It's just executing bytecodes on a stack, right? So if you write out your code object manually, you can have bytecodes that the Python virtual machine will execute that you couldn't otherwise generate using Python grammar and Python syntax. So, and that's how the magic introspection and monitoring Python expressions as they execute, that's how that works. It's because it's messing with the bytecode.
So it doesn't go from your macro language to an intermediate Python representation and then write the bytecode?
No. It goes from the AST, the Enaml AST, down to Python bytecode.
Okay.
Yep. Yes.
So, and obviously, from within IPython, we have taken the same chance of introducing extra syntax, which is invalid Python to provide other support. What are your thoughts if Python 3.5 all of a sudden picks up a colon equals operator, and now instead of being an Enaml superset, it becomes the Venn diagram has an intersection point with
Well, so fortunately, the grammar is context-free. And since we've introduced a keyword called enamel-def, which I'm sure Python's never going to adopt, everything under that colon indent I can do whatever I want with. So it's not going to mess with my parser or compiler at all. So anything else? All right. Thank you, guys.